In this video, we will be going over how to apply time domain filtering on two-dimensional inputs. So, as we had last time, these will be represented as images. We first need a couple of library imports: the OpenCV library, NumPy library, matplotlib, and we additionally need the SciPy library for the convolution function. First, let's read in our image and make sure we can display it all fine. Now we need to write a convolutional filter for our convolution function. In 2 dimensions, the convolutional filter is usually called a kernel. In our case, the simplest kernel that we can use is an ideal blurring kernel, which is a matrix with dimensions of n times n, and the kernel itself, all of the values in it, should be added up to 1, which means if we have a matrix of 1s that are n by n, then all of these values need to be divided by n squared. This makes sure that each of the points that we have in the resulting image do not go over 1. And here, let's just write the display function so we can show the kernel itself as well as the image. In order to apply the convolutional function, we just need to call SciPy's signal libraries convolve to the function and apply it to our image using the kernel as the kernel. And we can see that convolution as such has a blurring effect on the image. Now the convolutional filter itself, in this case, looks like a black image, but it is in fact a 21 by 21 matrix of values where each of the values are very close to 0, as the absolute sum of the values of the matrix are 1.